So, I just wanted to make another quick video and go over the Module 5 lab. I tend to get a lot of questions on that one. So, if we go down, this would be the one that is due next week, and it's titled Lapse Rates and Atmospheric Stability. So, I gave you a list of rules for air parcels. You might want to read that, but most of this information is found on pages 116 through 125 in your textbook. There are some pictures that should help you with this. And then open the document. Maybe. All right, so the first one, you had a similar one in Module 1, but basically the environmental temperature decreases as you go up in height. So if you start at the ground level, for every 1,000 meters you go up, you just subtract off 6.5 degrees. So if you start at 36 degrees, 1,000 meters higher, you'd be 6.5 degrees less than that, and so on. This next one is the one people struggle with a little bit, and that's filling out the chart. So you have two different columns here. You have a parcel temp and the environmental temp. I gave you an environmental lapse rate of 7. So this column, you would just subtract off 7 for every 1,000 meters you go up. And then for the parcel temperature, the rate it cools depends on if it is dry or if it's saturated. When it's dry air, it cools at about 10 degrees for every 1,000 meters. So as long as the air is dry, you would subtract off 10. Once you reach the dew point, which is 8 degrees here, once you reach that point, the air is saturated and it's not going to cool as quickly because water has a high specific heat capacity. So then it will decrease at a rate of 6. So you would subtract off 10 till you get to where the air is saturated, then subtract off 6 from there. And you can kind of use the textbook or some basic rules of thumb or the other attached document to determine if that air is stable or unstable. The last picture is how air parcels move over a barrier. And so like a mountain, again, we've got a dew point. I gave you the dry and moist adiabatic rate. You don't need to worry about the environmental lapse rate on this one. For every 1,000 meters you go up, as long as the air is dry, it would cool at 10 degrees. Once the air becomes saturated or, gets to or below the dew point, it would cool at 6 degrees. And then the air would be depleted of moisture once you get to the top. So it would warm back up as it goes down the other side of the mountain, and it would warm at the dry adiabatic rate. I hope this helps. And if you have more questions, please feel free to reach out to me.